And first off, we have Ingrid Heggland from the NTNU Library. Looking forward to it. Thank you.
Thank you. So first of all, thank you so much for inviting me. It's been a real treat to be here so far. So I work at the University Library at NTNU, and you might wonder why I'm here. Well, one of the reasons is because at NTNU, it's a library that we're trying to promote open science. We're trying to support researchers doing open science, doing research management, and think about best practice in research. We have basic support, so I also represent the research data at NTNU team, and we're the library and IT together, trying to give basic support and infrastructure to researchers. But now I want to talk a little bit about what, why, and how open science. And we've already kind of discussed this earlier. So this is just taking a step back, saying, why should we care about open science, and what do people mean when they say open science? And I want to argue that as a researcher, you are already doing open science, at least to a certain degree. And I've visited most of the institutes at NTNU talking about open science. And to be honest, you guys, you are doing pretty much open science compared to a lot of other disciplines and research fields, just so you know. So just to start out, what about defining open science? So there's not one definition everyone agrees on. It kind of depends on context or who is talking about open science, but there are some things that are common for many of these definitions. One example, to make the outputs of research open. That's one definition. That's maybe a narrow definition. Others say that the principles of openness should be expanded to the whole research cycle. So everything you do as a researcher should be open if possible. I would say that the second definition is more close to what we work with at the library and at NTNU, and you guys as well, as I have seen. And also the Research Council. They talk about the processes and the results being open. They also emphasize promoting quality and knowledge development. It's not just about shoving a PDF out there, it's about the whole process, how you develop knowledge. And the umbrella term open science, it can be a lot of different things. So this is a suggested taxonomy for open science. I won't talk about all of these, but I will mention this one that we have seen earlier, which are the main core. That's the publications, maybe the most familiar one for many fields. We have talked a lot about open data today, but also elements like open source, sharing your code, your analysis, open notebooks, so sharing methods, work in your project as you go along, but also the open peer review. So how do you evaluate research? Should that also be open? Scientific social networks, the collaboration networks, how you actually work together, what tools do you use? And also open educational resources and citizen science, involving even more people in open science and the open science practice. See, these are some of the facets. If I were to define open science, I would maybe say it's open and free sharing of knowledge in a digital world. Because this is important. We have new tools, new possibilities. The way we do and the way we share science has changed in the last 100 years. And I also want to emphasize the parts responsible, reproducible, and accessible. It doesn't mean open just to be open. It means open to promote good science. It's always as open as possible and as closed as necessary. So at NTNU, we work with these 4 core values for open science. It's about collaboration, working together, building on other people's research and findings, dissemination, sharing what you did, how you did it, what are your conclusions, transparency, showing what you did and how, and reproducibility. So hopefully these values, these terms are not really new. We have for many years talked about research ethics. It's an important part of research. And what I just mentioned related to open science, this is research. So I hope that we will stop talking about open science and it's just simply science. It's good science done in an open, transparent way. Sharing your methods, your processes, your results. And what I see here today, I see that we are really taking steps towards that. Although we still have a way to go, of course. So this is some of the ways we talk about open science and why open science. I mentioned the quality and integrity, making it more visible what you are actually doing, make it showing what you did, transparent research. But also from the funding side, it's also about making the most out of the money we spend on research. So economic benefits. If we can re-share data, reuse data, maybe you don't need to spend that much money on new projects. Open science might make research more efficient. If you get your output out there quicker, it can be reused quicker, it can be combined in different ways, it might help innovation, and we might have global benefits. So these are all these big, hairy goals for open science. And of course, public engagement and trust. Showing and being transparent what you do, how you do your research, it hopefully increases trust, both within research communities and towards the public. And one of the reasons we talk about open science or reproducible and transparent science is that many claim we have a reproducibility crisis. And I think this will also be addressed later today. But I just want to mention this study asking different researchers in different fields, do we have a reproducibility crisis? And over half of them said, yes, we do really have a crisis. They also asked researchers, so are you able to reproduce when you have tried to reproduce experiments? Could you reproduce? And over half of them said, no, not even my own experiments. I couldn't even reproduce my experiments in my lab. So we have a problem. Many reasons for this problem. Some state, for example, p-hacking, selective reporting, things like that. You want to have all these really cool, exciting results, so you might not publish the unexciting results, for example. But also sharing what you actually did, sharing your data, sharing your code, so others can go back and check it and look at it, reanalyze and reproduce. I think this is an important part of it. I just want to give an example of very non-producible research. You might have heard of it related to COVID-19. So there was a Lancet study looking at the effect of one of the medications, and then it was retracted. And one of the reasons it was retracted was people started digging into the actual data behind the publication. So in the publication they said, oh, we have this huge data set with data from hospitals all over the world. And then they started asking different hospitals, different countries, so how did you contribute to this data set? And it turned out they could not get any confirmation at all that anyone contributed data to the data set. So suggesting that the data set didn't really exist at all. And then two of the co-authors said, well, we haven't seen the data ourselves, so I think we have to retract. Which is pretty amazing that they never saw the data. So then Lancet said, oh, we are learning from this. We have now new guidelines. So when researchers submit a paper to us, at least two of the researchers have had to look at the data set. Not very impressive, but at least it's a step in the right direction. So an example of a journal that is a bit more forward-thinking is PLOS ONE. If you submit the paper there, you have to tell where can you access the data if you want to look at it. There are, of course, exceptions related to privacy, but you cannot say just data available on the request. That is not good enough. This is one example of working towards more transparent and more open science. And I want to mention the top guidelines, transparency and openness guidelines. So these are guidelines where you can go and check, what about the journal I want to submit to? What about my journal? How are they doing with data availability statements? What about pre-registration, code availability, and so on? And you can see how stringent are different guidelines for different journals. And this is really an important way for journals to help promote open science and transparency and reproducibility. So we at the library see many researchers come to us and they ask, how can I publish my data? because the journal said I have to publish data. So that's the main reason they know this is a thing they could and should be doing. So I think this is really important. I just want to mention a specific example. This is the journal eLife. Some of you might know of it. It's a relatively new journal. It's fully open access. They also have a very nice policy for data sharing. They also have open peer review, meaning you can see what did the reviewers comment, how did the authors respond as part of the paper. And quite recently, they have what they call the executable article. So I suggest you have a look at it. I just have a screenshot here. So they call it executable research article, meaning in the paper itself, in the online version itself, you can see the code. This is an example of the R script, I think, how they actually analyze their data. Of course, the data is also available. And then inline, in the browser, you can change parameters if you want to do slightly different analysis, run it and see how it affects results. So you can actually see step by step what data did they use, how did they analyze it, and what are their conclusions. And I really hope they continue with this, because this is really using the tools we have to show research output in a different way. So we've talked about research data a lot earlier today, so I won't say much about this, but this is one of the important things we at the library and at the IT department do to support researchers, and that I think most universities also try to do and are working on to help support good science, open science, and reproducible science. So thinking about what tools do you have as a researcher for each step in this research data cycle. And I want to emphasize that open science and good data management, they go hand in hand. Open science doesn't mean everything should be open at every point in time. It means you manage and document and make your data and code fair. And then you open it up if it is correct to do so. So we talked about fair. I won't repeat that, but it's very important as open as possible, as closed as necessary, but it doesn't mean it shouldn't be fair. Fair is always the starting point. And if you have the time later, there's this lovely little video about what happens when data is not fair. So if you have the time, please have a look. And we also emphasize the reuse of data. So we now talk about opening up the data, but that's for a reason. We want to emphasize, try to reuse data in an interesting, exciting way. So I would encourage you all to become real parasites. Those are Parasites Awards, awards people that are reusing existing data in an interesting way and then publishing a paper about it. So be a proud parasite if you have interesting data to reanalyze. And I want to give an example of a research project that is more or less as open as you can get it. It's called the Open Source Malaria Project. So they are looking for new medicines, new formulas for medicines for or against malaria. And they are fully open in the sense that whoever wants can contribute. They have fully open notebooks. They share all the results and data as it's produced. Everyone can suggest, oh, we should maybe move in this direction. How about doing it like this? Let's change up the analysis. And all the results, all the possible medications they get, should not be patented. They are free for all to use and reuse. So this is the most open project I've heard about, where they are really every step of the way as open as possible. Of course, this is the extreme. We're not saying everyone should do this, but you can pick parts that seem interesting, making it your project as open as possible and as open as sensible and useful for you. So we've touched upon this earlier today. So why aren't more projects more open, or why is open science something we're still talking about if it's just good science? We've mentioned the infrastructure. You have to, of course, have good solutions, technical solutions. I don't think that's the main problem. I think skills, you're a bit uncertain how to do it. It's new. All these tools you have to know about can be a bit daunting. But maybe most importantly, the incentives. So why should you do all this when you, as a researcher, already are pressed for time? Why should you do all this when the only thing that counts it seems like is your publication. Why should you then publish the data? That won't help you get your next job. I think this is changing, but it will take a while. And we are used to, our culture and practice is, well, this is how we do it. We publish papers and that's what counts. Process. Everything we do to make good science should be part of our output and part of what we're evaluated on. And of course, it takes time to learn new skills. It's also a bit scary, right? Publishing your code. If you have messy code, but that's so we shouldn't be afraid to put it out there, and then we at least can fix the mistakes if other people find them. And there are other initiatives to try to promote open science and transparent science. Many universities start to say, we want to show us what you do as part of your open science practice before we hire you. This is also slow in uptake. Some institutions are better than others, but I think this also will have an impact in the long term. And as mentioned before, also the funders, they do expect open science, transparent science, and reproducible science. I just want to mention a specific change. So you see this is dated April. So Horizon 2020, they quickly turned around and said, well, now if you get funding from us to research COVID-19, we have even higher expectations than before that you actually share your output. So of course, open access publications, that's always been an expectation, but they even say for research data you collect in these projects, within 30 days of collection, you should share it with the rest of the world. And now we're talking efficiency, and now we're talking sharing at a different level. And why shouldn't that be the default for at least some types of research? And there are, of course, a lot of interesting tools, platforms and collaborations that is nice to know about and can be really interesting to work with. Just a couple of examples. The Open Science Foundation, online tool for collaboration and sharing research data output. Also, the European Open Science Cloud is really good to know about. I won't go through this, but there are so many interesting, exciting tools out there working on open science. I suggest you have a look. Interesting and useful for me. So to sum up, open science, it's just science done well. You're kind of doing it already. It's not an either or, but it's a gradient and a process. It includes exciting tools, exciting collaborations and possibilities, and you're kind of already doing it. Thank you so much.
Thank you. Time for one quick question. So the first question up from Erland was, which fields of science are doing the best and why?
Oh, yeah, well, I can speculate a bit. I think you guys are doing pretty well. You're talking about standards. Not many other fields are doing that. Maybe the climate scientists and the physicists, they're pretty good. Yeah. Life sciences in general are pretty good. Yeah, that's a short answer.
Thank you. Well, we might go on to the next presenter. Thank you very much, Ingrid.